First of all, welcome back, everyone, and welcome to all the newcomers. My name is Jim Reed, Product Specialist and System Designer for RCF USA. I'm here with our producer, Anthony, and also here with our moderator for today, Oscar Mora. Say hello, Oscar. So we are going to be talking about some advanced techniques of Ease Focus 3. Oscar will be helping out. If you have any questions along the way, if I'm moving too quickly, if you have any quick questions, feel free to ask, and Oscar will address them. We will also be leaving about 15 minutes or so at the end of the session for Q&A, so I can answer some answer some questions directly. Please, let's limit the questions to the topic that we're talking about today. We will be covering a lot of things. If you have any questions about some other topics, please, let's save those for the other webinars that may address those topics directly. You could look at our schedule for our webinars on the RCF webpage. And if Anthony, if you don't mind just posting that, if you haven't already, posting a link in the comment section so people can take a look at that. Okay, let's get started. Let me share my screen here. Here we go. Okay. So what we're looking at right now is Shape Designer. I know we're talking about Ease Focus today, but I wanted to go over a couple topics quickly before we dived into the actual Ease Focus program and software and see what that's capable of. Both Shape Designer and Ease Focus are capable of giving us a lot of information. Both programs give more information, maybe more than the other. For example, here in Shape Designer, I did a quick prediction using 6 HDL30s listed here. They are suspended about 18 feet off the floor, and they are targeting roughly 100 feet of audience area here. Now, as we could see, Shape Designer, excellent in giving us information on mechanical predictions. If you need to do a quick prediction for a simple system and you need to know what your pick points are and your splay positions within the array, Shape Designer is an excellent tool. As you can see, it gives us gives us the weight of the array, including the flybar here, the hanging points. It'll also give us high frequency, low frequency compensation predictions as well, which is something that Ease Focus is not capable of doing. Also gives us atmospheric information here that we could change to give us different high frequency, low frequency compensation settings as well. Where Shape Designer stops short is SPL mapping. It gives us all the mechanical predictions, but it doesn't tell us exactly what the audience is hearing. It doesn't show us any of that SPL mapping. Sometimes we would like to know if the back end of an audience area is getting the same information as, say, the first half of the audience area. And that is something that Shape Designer cannot tell us. So I want to address a question that has been coming up very often since we've been doing these webinars and in general. And the question is, how do we know how many units to use in an array? How many speakers, how do we determine how many speakers we need to use? Or in another way of asking the question, we'll ask, how far will 6 HDL30s project? How far can that shoot? Or they'll ask, how many people can 6 HDL30s accommodate? And this is a very difficult question because there's many variables that we have to consider when determining how many speakers to use in an array. There's many different variables. So sometimes when we get asked these questions, it's difficult for us to answer. And then usually what I do when I'm asked that question is I'll follow up with a series of other questions for you, and I'll go through a list of all these questions, and then I'll finally determine how many speakers I think you need. But it doesn't really give you, didn't really teach you how I got to that point. So that's what I'd like to do today, is give you some examples of how I get to determine how many speakers are needed for a project or a venue or whatnot. And like I said, there's many different variables that get me to that answer. But to simplify things, there are 3 major variables that you should use, which will help you determine how many speakers you need. And those 3 variables: vertical coverage, distance, and max SPL. Sometimes these variables work independently. Sometimes these variables work in conjunction with each other. Vertical coverage, distance, and max SPL needed. These are the 3 things that we need to consider when determining how many speakers we're going to be using in an array. For example, let's first talk about vertical coverage and what is it exactly. Here we have a picture of the same example I used in Shape Designer. I have 6 HDL30s suspended at 18 feet, and throwing my audience area is roughly 100 feet. So we have the HDL6s here with the sound traveling in this direction. This is about 100 feet. We have the beginning of our listening area, which is indicated by this marker here. And we have the end of our listening area, which is indicated by this marker here. Now, the vertical coverage, the array needs to, starting from the grill, needs to cover at an angle to reach back here, and then also reach an angle to get to the front row. This angle measured here is the degree, the vertical degree of the array needed to cover the front row to the back row. Now, for this particular array, 6 HDL30s is covering this area very nicely. 100 feet, starting from roughly about 10 feet in front of the array to about 100 feet away. That's looking very good. But what happens when I increase my vertical area? What I've done here is I added a new plane, as you can see right here. Let's say that's a balcony, okay? I'm still using the same amount of speakers, same height, 18 feet. My distance from point A to point B is still 100 feet. My coverage area is still the same from the start to the finish. This is still 100 feet. But as you can see, let's get that. These 6 enclosures is not covering this area as much, even though the distance hasn't changed and the number of speakers hasn't changed. We're still throwing 100 feet. My vertical area has now increased, where now we have to project up here and as well as the front row, and this vertical area has now increased. And as you can see, towards the back, specifically up here, and as we look towards the back here, we're showing some SPL loss. So clearly, even though the distance is the same, 100 feet, by increasing the vertical coverage needed, it's already showing that I'm probably going to need more enclosures to cover this area. So by adding more boxes to the array, whereas before I had 6, in this one I have 9. In the first drawing, I had the top 3 enclosures targeting the balcony and the bottom 3 enclosures targeting the main floor. By increasing the box count, I've added a 4th box, so a total of 4 now aiming towards the balcony, and a total of 5 now aiming towards the floor. And you could see that this area is now, and back here, has increased and getting similar SPL coverage as the main floor in front of the array. So this is how increasing the vertical coverage, the vertical area needed to be covered, sometimes determines how many boxes needed in an array. Let's talk about distance. Here's a screenshot of ease focus. Again, using the same configuration. I'm using 6 HDL30s flown at 18 feet. But now, if we look here at our aerial view, I've increased the surface area, the area that we're trying to target. Instead of 100 feet, I've now increased this area to 300 feet. I've tripled the distance, right? So the question is now, sometimes, will 6 HDL30s cover, let's say, 300 feet? Where before we were talking about 100 feet, say 1,000 people in a 100-foot area. Now we're talking about what, 5,000 people in a 300-foot area. Will 6 HDL30s cover this? And the answer is yes. You could see here that the coverage is relatively smooth from the start of the area of the coverage area all the way to the back. And we could also prove that by landing these two receivers to measure our SPL. And if you look at the bottom of the screen, specifically in the vocal range around 4K, they're extremely close. So the intelligibility of the vocal range is going to be consistent from the front row to the back row for a 300-foot area with only 6 HDL30s. But there's an issue. Now we need to look at a different measurement. Max SPL in our distribution graph. As you can see here, our average SPL for the area covered is roughly 101.8, let's say 102 dB, average max SPL. Now, this particular system might work just fine for a public address, if it was just, public address, somebody speaking, maybe making announcements. We have clear intelligibility across the area, but at a max SPL of 101, 102, that may not be enough, say, for a rock show. So now we need to consider what the max SPL needed for a particular project, and is this enough speakers for that particular application? And if it was a rock show, clearly 6 HDL30s may not be enough. What's the answer there? Well, we could increase the amount of boxes, maybe to 8, 10, 12 HDL30s per side, or increase the size of the enclosure that we're using. Say we use an HDL50. Now, these are when the other variables, other than the main three that I mentioned, come into play. Right now, we're talking about vertical coverage, distance, and max SPL. But there are many more variables that we need to take into account, such as, for example, let's say the trim height of the truss above the stage. Sometimes we don't have control over that. And if we're only working with an 18-foot truss and we need to hang 10 or 12 HDL30s, well, that's going to be too large of an array for that height of the truss. So that's one variable. Another variable may be the budget of the client or the budget that you're working with as well. That also determines how many boxes that you're able to use. But at least we can now use, we know how to see in ease focus, taking measurements and how our SPL mapping is covering a particular area in terms of distance and vertical coverage, and we could predict how many boxes, we have a start of how to predict how many boxes we need to use in an array. I think that's all I have for these slides here. Good. So now that this is said, please keep in mind everything we just talked about now as we go into designing our project for today. Let's close all these down and let's open up an ease focus project. Okay. So the first thing we're going to talk about today in ease focus is importing a picture, say a drawing as a background, so we could overlay our system over a picture. So to do that, we could, this is the default view of ease focus. Let's remove this box, which is unneeded at the moment, and we're going to import a picture. To do that, we're going to come up to the toolbar where it says layout picture. We're going to click here, and we're going to find the picture of the drawing that we've already created on your computer somewhere. Here is a venue that I worked on in the past. First of all, when importing a picture into ease focus, it's important to remember you cannot import PDFs or architectural drawings like AutoCAD or any type of DWG file. Ease focus only allows you to import JPEGs or BMP type of files. So if you're looking to import a picture like this and you're working with, say, an AutoCAD drawing or an architectural drawing, what you're going to have to do is, at least what I do is I'll use the built-in app for PCs, the snipping tool, which I have here in my toolbar, which allows me to take a screenshot of a particular picture. And that's how I will import it into EaseFocus. Now, once we get to this window here, we could hover around the area. We have a stage area off here to the left with our audience area over here. Fairly wide audience area, but it is symmetrical, meaning that both the house right side of the venue and house left side of the venue are identical. And there's a magnifying glass off to the side here, which will help you make our measurement points. So what we're doing here in this window is bringing this picture to scale. There is no scaling on this particular picture, but I've already opened up this this AutoCAD at another program and made my measurements. I know that from one corner of the room to the other corner of the room is roughly 128 feet. So what I'm going to do is drag these 2 points from one corner of the room to the other. I'm going to make sure that I am being as accurate as possible when doing this, because this is going to determine the scaling for the rest of the room. And when the rooms get larger, even the slightest mistake can turn into a big mistake as the scaling of the room increases. Okay, so once I've put the 2 points at both sides of the room, like I said, I know this distance is going to be 128 feet, so I'm going to put that line length here, 128. For the point A coordinates, XY coordinates, that means it's going to be taking measurements from this area right here of where our zero coordinate is going to be, our global coordinate. This is an important step here. It's important that we start by entering values 0 for both X and Y, and I'll explain why I do that in a moment. First thing that's important is putting the length of the line and adding 0 points for point A. And then we hit, okay. Now, the picture is populated on our eagle eye view of the screen. And as you can see, the XY coordinate right here is located up here on the north end. And that's not where we want it to be. And the reason why, what we're dealing with here, and in most cases, is a symmetrical venue. Like I said before, house right seats are identical to the house left seats. The seats are all in the same exact position. It's a mirror view, which means that we want our system, ideally, our audio system, to be symmetrical as well. And in order to be precise when creating a symmetrical system, we need to be able to take a measurement point from a central location and measure all of our speaker locations from that center point. And it's important to do that now in the creative process here when we're designing our system, so that when we actually show up to the actual venue, we'll take the measurements from that same point when we measure where to put our speakers. The best point to measure, I find, for most situations, is the front lip of the stage, which is going to be right here. I could zoom all the way in. Here's the direct center front lip of the stage. That's where I want to put this XY point right here. How do we do that? I'm going to hover my mouse over the front center lip of the stage right here. As I am doing that, I am looking at the bottom left-hand corner of the screen where it shows the X and Y coordinate of the mouse. You can see the numbers changing as I move my mouse around. So I'm going to zoom right in on the front lip center of the stage, as close as I possibly can for this webinar's sake, and look at the bottom left-hand corner, and I see that it says 23.58. I'm going to write that down, and 90.39 for my Y coordinate. 23.55, 90.39. Let's zoom back out. Now we go back to the edit layout picture. We go back to the XY coordinates where we entered 0 before, and we're going to enter these new values that we just determined, 23.55 and 90.39. Hit enter. And now we can see our XY has came up right in the front. right in the front center here. So now when I drop my speakers, let's put in a system here. I'm going to use the HDL 28 today. Let my computer think a little bit. We're going to drop this over here. Okay, so now when I put my speaker, my right array over here, I want to make sure that when I put my left array on this side of the stage, that it's in the exact same position as the other array. If I didn't put my XY coordinate right here in the center, I'd be guessing to see where the arrays need to be. I'd be moving them around and kind of get them in the right location. But by doing this, what I could do is click on say the right array, go to my XY field, and let's say I want the X value to be, we'll make this, I'll just round this to an even number, 8. And we want my Y value, which is left to right, to be, let's say 20. So 8 and 20. Now I just go to my left array, and I enter again, 8, 20. Now I know both arrays are the exact same position physically in this space here. And this is a very helpful tip right here to put this XY coordinate right here in the middle. It's going to make creating systems like we're making today, or even larger ones, much easier, because everything will be identical on the left and right hand side of the venue. Plus, when you show up to the venue, the actual venue to set up your system, you'll be able to take those same measurements from the front center lip of the stage and go -8 feet back and 20 feet to the left or 20 feet to the right, and your speakers will be in an identical mirror position. Okay. The next step that we'd be doing now is we would be creating our audience zones. This is probably the most time-consuming part of creating an ease project, for me at least. I spend a good 70 to 80% of my time making sure that when I draw these areas here, if I put a stage here and we start putting our audience area here, I make sure that my measurements are as accurate as possible. It's like they say, measure twice, cut once. If I make any mistakes from the beginning, it's just going to be accumulative, and those mistakes are going to stack up and eventually give us the wrong data by the time we finish our system, because our measurements were off from the beginning. So this takes the most amount of time. If you're designing a system for a live show, or if you're doing an install, make sure you spend extra time making sure this is perfect. For time's sake, for this event, for this webinar, I've already created my zones here. Same area now with our zones. Okay, before we go any further, I'm going to add another plane in this area. I'm going to add a balcony. The balcony for this particular venue is going to wrap around the entire length, the back end of this venue. So to do that, we could see down here, we have our side view. I'm going to click on this object. I've already named all of my objects. This one highlighted in red, I'm calling the main floor center. And off to the sides, we have main floor right, and then we're going to have main floor left. But now we're going to add balconies. So let me click on main floor center. I'm going to click add area right here. And as you can see, it's already populated this object area with a new plane, which is going to be our balcony up here. Now, this is the time where you're going to have to cross-reference the measurements that you made at the venue, or your AutoCAD, your PDF architectural drawings, to make sure that now that the measurements of this balcony are going to be as exact as possible. For now, I'm just going to make it up because I'm not going to go through PDF drawings with you now. So let's say that this new area that we entered, and we can see the values for this new area are down here. Let's name it. So we're going to call this the balcony center. And we're going to enter the values of where this balcony lives in space here. Let's say that it starts 40 feet from the stage and goes all the way back. And the front height, Z, is the height of this plane. The first value is the start of the plane. The second value is the back end of the plane. So if I could see if I can move it from here and grab this, as I move this up and down, you'll see the value change over here. So let's keep this at 12 feet and we'll make the back end go to 20 feet up. And now we've just created a balcony in center here. We can now do the same for the other areas here. Let me go back to the center here and just go through one more thing. Let's, I started the height at 12 and 20 on the back end, and the degree, the angle of this plane is 14.86 degrees. So if you're doing a site survey and you're measuring this on site, if you're capable of measuring the angle of the floor, so a lot of smartphones can do that. You just put your phone on the floor and it'll tell you the degree of the plane of the floor. Now you can just go right at the ease and enter that value right here, and it'll automatically give you the degree angle of there. So let's go to the side areas and also add some balconies. I'm going to add area here. I'm going to call this balcony right. Again, I'm going to start it at 12 feet. As you can see, it's not quite lining up here. We're going to change the values to make sure this is correct. Let's do 28. Right now, what I'm doing is lining up these dotted lines, which indicate the start of the balcony. I want to make sure that it's even going all the way around. And it looks fairly even here, and I want to make sure that the angle is correct as well. I know that the bottom of the balcony here starts at 12, but I want the angle to be roughly 15 degrees like it is in the center. So now I've created a balcony in the center, and I've created a balcony off to the side here for this object. Now I could do the same thing over here, or I could just highlight this object since it is identical to this side. I'll highlight this one, come over to the left here and say, go to copy area. Click that. Since I named all my areas, it's easy for me to distinguish where I would like to copy and paste that automatically. I'm going to copy this to the main floor left side of the room. Click there, click OK. And as you can see, it automatically gave the same settings that I did on the right side of the room to the left side of the room. Now we have a venue. We could see the stage down here. We see the main floor, and now we have a balcony. Let's drop in a sound source. Again, we're going to use the HDL28. And for the sake of consistency, let's start this array like we've started the other arrays in my other examples before. Let's turn off show mapping right now and only use 6 enclosures like I was showing before. And let's see how this reacts in this venue here. Let's make sure that everything is center and the height of the array is where we want it to be. I want the Y coordinate to be 0, which would be in center. By the way, so I'm putting it in the center of the room right here because of the width of this venue is fairly wide. We're looking at roughly, I don't know, about 120 degrees. From experience, I could say that most likely just a left and right array will probably not cover this area by itself. We're either going to have to approach this design with a LCR, a left center right array configuration, or if we did a left and right array, we'd probably want to consider a center fill to cover the area where the left and right arrays cannot reach in the middle. But I'm going to start by putting an array right in the middle because I want to see what 6 boxes does in a space this size with this many planes. 6 HDL28s. I'm going to fly this at 24 feet, making sure it's centered to the stage. And I'm going to put it slightly upstage. 3 feet upstage. I don't want the array to be over the front row people's heads too much. I'm going to give it a little bit of distance there. So let's see what happens when I hit auto display. Let's see what the program wants to do on its own. It's going to, by clicking auto display, it's going to give us a new dialog box here, asking us which boxes we want to display. We want to display all of them. It's going to ask us what kind of display strategy. We're going to go with the conventional. And it's also going to ask the target areas. What do we want the arrays to be targeting? What areas? And as you can see, because we named all of our areas, it's easy for us to distinguish here. We do want to be hitting the main floor, the center, and the balcony. We do not want to be focusing the array on the stage. So I'm going to unclick the stage here. So now when it makes its changes, it's going to make sure not to focus the energy on the stage. Let's see how that looks. And it looks like we saw before in my other examples. It may be kind of weak. We only have 2 boxes focused at the upper balcony, and we have the bottom 4 at the lower balcony. And we could also see that the bottom 4 aren't quite reaching the back under balcony as well. So that's something to consider for later on in the project, maybe adding under balconies. Let's take a look and hit show mapping to see visually how it looks, and look at our SPL mapping. And that shows us a degree of what's happening here, but not very accurate. It shows us the colors and the SPL mapping, but what does it really mean? It's not very exact because of this color mapping. We're going to need to use more tools to find out exactly what's happening in the front row and in the back row and in the upper balcony as well. So in order to do this, we're going to have to drop what's called receivers, which can be found here in our toolbar. We're going to click a receiver. And what these receivers are essentially, they're reference microphones. And it's going to take a measurement of our SPL and frequency response at each location that we drop it in. Let me just click on this. We're going to lock this here. By using this lock function, if I click on any object and hit the lock button, now I can move other objects without the screen changing. If this was unlocked, every time I click a new object, the side view is going to start changing in relation to what object I'm looking at. But if I want to lock this side view, we just click right here. And now I can click anywhere in my aerial view and my side view will not change. And I can take this receiver and move it around where I want it to be without affecting anything visually as I work. So I'm just going to drop some receivers all the way around here, as I like to draw a straight row of receivers directly in front of the line array. First, I want to focus my receivers on the floor and then on the top. If my receivers end up popping up on the balcony, we could just click on the receiver here and just drop it down. So I'm going to put 5 receivers on the bottom floor, and let's add some receivers on the balcony as well, so we take measurements up there. I'm going to put 3 receivers. I want to make sure I put a receiver at the front row of the balcony, maybe one in the middle, and then one at the very end. So I could take a nice broad spectrum of measurements across the whole area. Now, without even turning on show mapping, I can now measure my SPL by looking at the frequency response of the receivers that I just dropped in. And as we can see, it looks pretty good. The Ease Focus did a pretty good job of focusing the array where we needed it to be. Let me click this here. As you can see, it's not showing me anything because I forgot to unlock that one receiver before. Once I unlock that, now I can move around again and see things independently. And it's not bad, although I am seeing SPL drops in certain areas. What I'm focusing on really is around 2K, 4K specifically, which is the vocal range. I'm looking for intelligibility. That is usually priority for most applications, especially say we're in a theater or a church. If your vocal intelligibility is off, the system's not going to sound good. And most of the time, if anybody's ever asking to see your Ease project, they're going to want to see what's happening focused at 4K. In order to do that in our SPL mapping, up here at the top bar, we're able to choose the frequency that we want to see in our SPL mapping. So let me turn this back on. By clicking 4K up here, the frequency window, I can now change the frequency that I want to see the SPL mapping to be working at here. And I like to work in the 3 octave as well. So if we wanted to see 315 hertz, and we can work our way all the way down through the frequency and all the way back up to the frequency spectrum. But again, we want to be focusing on 4K. If we don't have that right, nothing else is going to be right. As you can see, things look pretty good, but we do have some SPL drops at certain areas. You can see the colored lines down here, which indicate the receivers. We can turn on and off these receivers by right-clicking on any one of these. So if we only want to see a specific group of receivers at a time, we could turn off the ones that we don't want to see. So for example, we dropped 3 receivers in the upper balcony area. So if we want to see what's just happening in the upper balcony area, we could turn off all the other receivers by right-clicking on them and only leave receivers 6, 7, and 8. And as you can see around here, it's looking pretty good. But if we wanted to focus and get that a little bit tighter, now we could just turn off the other receivers and we could see how we're working. If we only wanted to see the main floor, we turn on the main floor receivers and turn off the upper balcony if we're not focused on that. So the main floor looks a little crazier. And why is that? Well, for one, number 5 receiver all the way on the back here is not getting any directivity from the array because the balcony is blocking it. So we, as I mentioned before, we're probably going to be putting under balcony enclosures and mounting them on the ceiling under the balcony to reach that area. So I know that my main array doesn't need to be focusing on this number 5 receiver because I plan on putting an under balcony in there later in the future. So what I could do for now is turn off receiver number 5. That's unnecessary information. We could turn that off. Excuse me, I had a cough. Okay, so still a little crazy down here. We can start making adjustments. It might be now time to consider using maybe more enclosures to get something a little bit more accurate across the board. Let's try that. Determining how many speakers we need sometimes just comes down to experimenting. I started with 6, maybe it takes 7, maybe it takes 8. I'll start small and work my way up until I find a number that I'm comfortable with. So let's add some speakers. Let's make this center array a total of 8 and see how things improve. I've now turned this to 8 enclosures. Let's hit auto display again and let the program do its magic and get us in the ballpark. Let it think. Okay, so now E's made some mistakes I could see right away. It's focused more speakers on the main floor, good. It's still left us with only 2 enclosures focused on the upper balcony, which I'd like to change. Plus, the 3rd speaker from the top looks like it's pointing right at the balcony, the front balcony wall there. That's wasted energy pointing at an area where nobody's sitting. And it could also create reflections off that balcony wall too, which could bounce back towards the stage. So we're going to correct this manually. In order to do that, we could change the array position off to the left here. I like where this top array is pointing right now. It's pointing directly towards the back seat, which is good. Before I make changes to the display position for each box, I want to make sure I know what's happening with this pinpoint box right here. What is that? And what does that do? The pinpoint will, by either clicking or unclicking this box, will lock the frame, the fly bar in its current position or turn it off. With the box unchecked, I can make changes to the display positions between the boxes, and the fly bar will not move. But if I did have this checked and made changes to my array, you can see now the top box has since the center of gravity has shifted, the top box is now pointing too high. So what we want to do is unclick this box so that it locks my fly bar in place as I make new changes to the bottom boxes here. Let's get back to where we were before, since I made all these incorrect changes. All right, so again, ease focus has made an incorrect prediction here. It's not showing what I'd like to see. So I'm with the pinpoint box unchecked, which leaves the fly bar in its locked position. I can now make changes to my splay position between each box. I want to focus more enclosures in the upper balcony. I would like to put 3 enclosures focused on the upper balcony and the remaining 5 bottom enclosures on the main floor. So let's do that and tighten up the spacing between the top arrays first. I changed that to 1.7. This next box here, which is at a 7-degree angle, which is now pointing too low at the balcony area, I'm going to tighten that up as well. Let's get that to something a little bit more comfortable. That looks good for now. Now I need to create somewhat of a gap between the 3rd and the 4th box so that it now is not targeting the balcony face. I want to get that more towards the floor. So let's increase that angle. So let's start with 5 degrees. That's better. I still don't feel that's enough. I'd be worried that it'd still be hitting the bottom of the balcony wall there. So I'm going to take that from 5. We'll go to 7, and that's looking a little bit better. And now we can start focusing on the remainder boxes here. That's looking pretty good. Let's take a look at the frequency response and see how that's looked. Let's turn on all the receivers that I turned off before. And that's looking good. Again, this number 5 receiver, which is the under balcony, is still fairly low because I don't have the under balcony enclosure in place yet. So let's turn that off because I'm not really concerned about that receiver. And I'm still showing, it might be hard for you all to see, but the 8th receiver, this light blue line, is still rather low, which means that I probably have to make some final adjustments to my top, the display position between my top 2 boxes. Let's go ahead and maybe change that now just to show you. In fact, what I'm going to do is I'll leave the frequency response here. Let's turn these all off, except, whoop. I'm going to try to get, it's probably difficult for you to see. There's a light blue line at the bottom here. I'm going to try to get that close to the other receivers by decreasing the display position between the top 2 boxes. And that has cleaned up quite nicely. Let me do that again. Go back to 1.7, to 0.7 degrees. Let's look at it from the side. 1.7. We're looking at the top 2 boxes. To 0.7. And we could even, if we want to, manually shift the fly bar up to maybe target the top seats a little bit more by clicking the pinpoint. We can manually change the pinpoint, which is the pick point position for the fly bar. I'm going to pull it back 1 position, and we could now watch the array tilt back up a little bit. By doing that, I may need to increase this box position here so that it's not hitting the balcony face again. So let's move this to 10 degrees. Oh, I made a mistake. Let me bring that back down to 7. And I'm going to uncheck this pinpoint because I want to lock the fly bar. Uncheck it. Now I can make my change here without changing the center of the vertical position of the fly bar. There we go. Now let's take a look at our frequency response. Probably was better before. I probably should have played around so much, but this is my point. Sometimes it takes a little bit of experimentation to get things right by adding more boxes, changing the display positions. This is why we have the program, is so that we could experiment with different box counts and different display positions and see what the results are going to be. And with a little bit of time, we're going to get to a point that we like. Right now, I don't like it. But we're experimenting right now. With a little bit of time, we can get it, I'm sure, closer where we want it to be. That looks pretty good. But once we find something that we like, now we could start entering new parameters for this array. This is an RDNet ready box, the HDL28. It has RDNet on it. We can make high frequency, low frequency compensation changes, and we can apply them in ease focus as well. In order to do that, we'll probably have to open up our shape designer software that we were working with before. We would enter the same line array that we're working with here, 8 HDL28 boxes. We'd have to re-enter all the object plane dimensions, the distance, the balcony, and then once Shape Designer has given us the high frequency, low frequency compensation presets, we could then click on our array, go to our filters for this array, and we could enter them here. We open up this box and we can see a little bit more. We have our low frequency compensation, which Shape Designer might have given us at 2.1, 2.2, and then also high frequency compensation to give us a little bit more energy in the higher frequencies to reach the back of the room in the upper balcony. For example, it might have gave us values, something like 6, 5. This is all something that Shape Designer would be able to predict for us. And as I make those changes to the high frequency, low frequency compensation presets, it's also making changes here. For example, if I change the low frequency compensation filter back to 1.1, you will see a bump increase happen in the low frequencies again, like that. Go back to 2.2, we'll see that. And if I make high frequency changes, we'll see that as well. This is not a very large room, so we may not see the effects too much here, but let me change it. Let's bring this back down to 1. And you can see things happening as I make my changes, just to prove my point that it is effective. By adding the high frequency, low frequency compensation changes, we're able to get different results in our measurements. At this point, if I'm comfortable with the center array, I could now start adding my left and right arrays. If I know that the seating area is going to be identical, I could quickly just copy paste the center array. I could take this array here and drop it off to the right. If I know where I'm going to be hanging from, if I know if there's a particular I-beam or if there's a truss installed, these are things that you need to determine before creating your ease model to make sure that you're accurate. But just for time's sake, I'm going to say that we're going to hang the array here. We're going to at a 45 degree off axis from the center array here, and I can make sure that's accurate by clicking on my horizontal degree position here, clicking in 45 degrees, making sure that's exactly 45 degrees. Let's name this right. Let's show map. And at this point, I would start adding more receivers. I would now add another receiver on the right side just to confirm that my measurements are correct. I want to be taking measurements from the middle. I want to be taking measurements from the right side of the room. I want to be taking measurements from the left side of the room. Let's go ahead and click here. My side view. I'm going to lock this as I drop in more receivers. I'm doing this rather quickly. What I just did was the same thing that I did in the center of the room. I added receivers on the bottom floor, starting from the front row. Working my way all the way to the back row of the first floor. And then I also added receivers on the balcony as well. So now I can compare these measurements. And as you can see, things are staying pretty linear right here. My frequency response is staying fairly accurate. I could turn off the first 8 receivers so that I'm only looking at the right. I'm only looking at the right array. So right now I'm only taking measurements of this right array here, and I can make my any changes that need to happen for this side of the room. if it's any different because maybe the balcony is a different size or because of the position of where the array is hanging, I need to make new positions. But now I'll be able to compare my receivers from one side of the room to the other side of the room, and I can turn them all back on. And we can now prove our frequency response going back and forth. And now, as an added bonus, I will show you a little sneak preview of what we're going to be going over next week. Next week, I will be talking about subwoofers. So if you have any questions about subwoofers today, let's think about them, save them, and we'll add them for next week. I'll show you something that I would do if this was a church. Oh, made a mistake. Let me unlock this down here. If this was a church and the church has already notified me that they do not want any subwoofers on the ground, we want to fly subwoofers. Let me delete this array. Delete. Let's add a subwoofer. I'm going to use the HDL38, which is a flyable single 18-inch subwoofer, also with RDNet, so we could tie it into the main system. The HDL38 subwoofer is a companion sub of the HDL30 speaker, which means it needs to fly off of it's a separate flybar from the HDL28. Remember, we're using an HDL28 for the mains here. So what I need to do is drop it in my HDL30 system, and I'm going to fly it behind the center array. I'm going to fly 2 subwoofers. So I'm going to click 2. By clicking the drop box for the HDL30, I can now switch this to the HDL38. I'm going to do that for both of them. I'm going to make sure my subwoofer is center. So I'm going to put that at 0. I'm going to move this subwoofer a little bit closer to the main array. We can watch the bottom screen here. And there we go. And now we can look at our show mapping. We can look at, let's change the filter here. Let's change this to L4. And now for our mapping, we can look at not only what's happening at 4K, but we could drop this down all the way and see what's happening down to the lower register, let's say down to 100, 63, and we can see what's happening there. And we could also take 3D imaging as well into account. So now we can take measurements of exactly where the subwoofer is flying in relation to the main system. This is a subject that I'll be talking about next week as well. So I think I covered what I wanted to cover today as far as how to work with measurement tools within EaseFocus 3 using receivers and using them to help determine how many units we need to use in a line array and the factors that we need to take into account when determining how many boxes to use within. So let's open up the floor for questions. The schedule for next week will be available soon. I think Anthony should know, probably be released tomorrow or Thursday.
Are you saying the schedule for next week?
Yes.
It comes out on Friday.
Oh, the schedule for next week comes out on this Friday of this week.
Friday morning, yes.
Got it. Okay, let's open up to the questions here. Can we put the moderation back on, please, Anthony or Oscar, so I can go back to the moderated? There we go. Thank you. Okay. off-topic question. This kind of venue shape, if you're using system speaker left, right wings, what is the plus minus compared to LCR system? Oh, so what? How do I determine whether I use an LCR system, say a left, center, right array of the same kind, or just a left and right with a center fill or out fills? Um, that's a good question, but a difficult one to answer. There's certain things I need to take into account. We need to take into account, especially when we start hanging a center array. Not a lot of venues will prefer that because of aesthetic reasons. Sometimes there is a visual effect maybe happening behind the center array, like a stained glass window. Maybe there is a projection screen or an LED wall that we need to take into account. There could be a chandelier directly in the middle of the room, which is blocking us from hanging anything in the middle. So these are all things that we need to take into account when determining what will be best and make compromises. For this particular venue, the most ideal configuration was an LCR. And by verifying with the client that I was able to do something like that, I continue to use an LCR system. Good. Do we have any other last minute questions? I hope I was clear about everything. I feel like I moved rather quickly today. We're all good? Oscar, do you have any questions? Be sure to tune into Oscar's webinars coming up soon. He covers a lot of great topics, and Oscar's a genius when it comes to this as well, too.
Hey, Jim.
Yes.
Paul Folkshead has a question about optimal file type for this picture layout. Is that, I assume that means what you can import, and it's
Correct.
PDF, right?
No, it is not PDF. So Ease Focus does not allow you to import PDF or any type of AutoCAD files such as DWG or anything like that. The only thing it does allow you to import are pictures, such as JPEG or or BMP type of file. I mentioned earlier before what I like to use. I think I'm still screen sharing. Yes, I am. On PCs, there's a built-in tool or app called, if you search for it, it's called the snipping tool, which allows you to take a screenshot of what you need to take. So once you can take a screenshot of a PDF file or an AutoCAD file, save that screenshot as a JPEG or what have you, and then import that JPEG into Ease Focus. Flying the subwoofer will be strictly behind the line array. Sometimes, again, that is one example of a sub solution. Again, I'll be talking about subs in more detail next week and why we may need to fly a subwoofer behind the main array, why we may not. There's many, many things to take into consideration there. Any other questions? Let me go through here. Okay. Oh, there are more questions. Okay, bear with me. Let me go through these real quick. Oh, the maximum acceptable discrepancy of SPL at 4K. So what am I trying to achieve when taking my SPL measurements? Most industry standard is plus or minus 3 dB. That is on the high end for me in most applications. Sometimes because of budget reasons, we sometimes just get as close as possible. But for the most part, say for a system like this, and what he is referring to, if I can clarify, go back to my frequency response. Let me turn off the receivers that I don't need anymore. We're talking about this area and what should be that discrepancy. Yeah, so plus or minus 3K. If you hover your mouse over this area, say to the top, the highest SPL point, and look at the bottom left-hand point of the screen, it's going to show SPL. So at the highest point at 4K at that receiver is 106.3. And then it goes to 103.7 and even worse at 101. So there's about a 6 dB discrepancy between the highest point and the lowest point, this orange line. So that means that orange line, that orange receiver, number 6, where is that? Where is number 6? Got to go to my side view. Number 6, it was the front seat of the upper balcony, which tells me that the front seat of the upper balcony is be receiving less SPL than any other seat that's in line with that main array. And my goal is to get, to answer your question, within plus or minus 3 dB. Let's go on. Next questions. Can you also drag lines when determining display angles instead of adjusting the drop-down angles? Yes. I don't often do that. I find it a little clunky. You can move the array up and down by grabbing one of the speakers and moving it up and down. Yes. Is there a possibility of static interference of speaker 2 to a big monitor screen placed beside the speaker? Yeah, I see what you're saying. So if there's a large video screen near a active line array, will we hear any interference? You're talking, yeah. So sometimes RF will bleed through. Sometimes a lot of that is dependent on how well the electricity is run in the room. That's usually a grounding issue. If that does happen, if everything's done correctly, you could have the arrays fly fairly close to screens without having any issue. It happens every once in a while, but it's typically not because of the speaker and the screen being too close together. It usually comes down to an electrical issue. What is the lift button do in filter view? Oh, lift. Oh, I see what you're saying here. I believe it's just a quick way to increase and decrease the filters, as we mentioned before. This might depend on how things are grouped. This is something I don't experiment with, to be quite honest, because I don't determine my high frequency, low frequency compensation settings in the filter window here. I usually let Shape Designer determine that for me, since it's much better if we're doing that virtually, determining what's needed. So I'll jump back to Shape Designer. I'll enter all the same, as much as the same information as I can in Shape Designer, and find out what that software determines for high frequency, low frequency compensation. And then I'll just copy that and manually have to enter that in my filters for ease focus. There's a mandatory subwoofer hanging the backside of the original. It's not mandatory. Again, there's many different configurations for subs, which I'll go over next week. Can we group the sub and the HDL28 together and move them? Unfortunately not. I do wish that was a feature that Ease Focus offered, where we could highlight multiple sound sources and move them together. Unfortunately, you can't do that. So if you have to move one speaker exactly 2.3 feet, then I would just go ahead and move the other speaker 2.3 feet separately, independently. When making the room, can you insert obstacles like chandeliers in a ballroom? Okay, so that's a very good question, and an important point that I forgot to mention in this webinar is that Ease Focus in general does not take into account any room reflections at all. This is a static environment, meaning it does not take into account the reflections of the walls, the floor, the ceiling, and the surface material of each of these surfaces. So whether if the floor is carpeted or a hardwood floor, or if there are windows on the walls, or if there are chandeliers, or drop ceiling, or acoustic tiling, it does not take into account any of that. This is only taking measurements of how speakers interact with each other, not so much of how they interact within a room. If you want to take measurements of how a speaker interacts inside of a room, then you have to purchase the full version of EASE, which will then take into account room reflections and objects. Anybody else? Did I miss any questions? I hope not. Placing the sub behind an array, do you have to consider phase issues? Not if the sound sources are crossed over accordingly. If we are crossing over, if we're letting a low pass filter on the subs and a high pass filter on the highs, and we set our crossover points, we do not want the sound sources to be generating the same frequencies. So we should not be experiencing any phase issues between subs and tops. How we doing, everybody? Did I miss anything? I think I got all the questions. Any last minute? No? We're doing good? All right. Maybe we'll end this one a little bit earlier. So again, I see somebody's typing, but while they type, we'll be posting the next week's schedule on Friday. We're going to have some new topics to discuss next week, including subwoofers within EASE focus. And I'm going to do my best to explain that. That's going to be a difficult subject to cover within EASE. But it looks like we went through everyone's questions. Again, thank you, everyone who attended. Thank you for your questions. These were great questions today. Thank you, Anthony. Thank you, Oscar, for moderating. And oh, we got somebody typing. Let's let some last minute typers come in. I don't want to cut you off. We're good? Everyone's saying thank you. Well, thank you. Very good. Again, everybody be safe. I will be back next week. Please check the schedule on our website for other topics that are happening for the remainder of this week and going into next week as well. We're all doing our best over here, staying safe, staying healthy, and hoping for some normalcy to come back again soon. All right. Be safe, everyone. We're going to go ahead and end this session. Have a great day. Have a great night. And I will see you all soon.